How's everybody doing today? Welcome to the Making Awesome Podcast, Season 2, Episode 24. We're going to be talking about the types of 3D printing and why they should matter. We're not going to get too deep into a lot of them because ultimately I could spend all damn day on this, and I don't have all day. But before we get too far, I want to give a quick shout out to the Tampa Bay Aero Club. I was just out there earlier working with the club, and it's really cool because it's right off of a municipal airstrip. So they were actually taking up Boy Scouts today in private planes, which is objectively really cool. And I feel bad because I didn't know that I could also be doing it too. So I might be going back out there to go fly in a private plane because that kind of thing is a lot of fun. I have my co-host coming up with me. Come on. Thank you, ma'am. Come on. Stop it. Get in your in your bed. Please. Please and thank you. Co-host. Co-host. Be a good co-host. Come on, cat. I love you. Need you to be in your bed. Oh, who's a good cat? That's right. We got the cat today. Advertising FJ Prince says, welcome everyone to the stream. We've got Zerno, Ronnie, Duff, Chris Catlett, Jake, Shotgunner 5609, Jimmy Johansson is here, FJ Prince is here as well, and the cat is just needing all of the attention because that is what this cat does. She needs all of the attention. All right, my dearest, come on. We have a job to do. We have to stream. No. We have to stream. Okay? This happens every time I go to film a video. If she's in this bed, she always wants to be a pain. But hope everyone's enjoying their Sunday afternoon or Sunday evening, Sunday morning, depending on where you are in the world. It's been a lot of fun. I did not expect to be going to a private airport today, but, you know, some days are more interesting than others. Might film some content out there, but it's not going to make it into any videos. But I'll be filming content for them likely later today. The head of marketing. Yes, the head of marketing is here. Oh, the head of marketing. My good girl. So we're going to be talking about a bunch of different types of 3D printing. We're going to do FDM, FFF, SLA, MSLA, DLP, SLS, MJF, LPBF, and other metals. Binder jetting, which I'm not a huge expert on, but I'm hoping to have one on relatively soon. CJP, and then why you would choose certain types over others. Because there are reasons, and there are reasons that you might choose to do some over others. Stop it, cat, stop rubbing on the microphone. I love you, but the stream. We have to come here. All right, you can sit in my lap, I guess. You can sit in my lap. Yes, the kitty likes me, and the kitty always wants attention when I'm going to film, and that means it can be a pain when I want to stream. So sorry, but those of you that have been here for a while kind of know this is how this goes. But this is a very good cat who just wants all of the love and attention that she can possibly muster. Anyways, let's get into it. A lot of you all are familiar with FDM and FFF, which is the main filament-based 3D printing that everybody is used to. It is affordable, it is easy, and for the most part, it's fully open source. And that means it is incredibly easy to obtain. And with how the tech has grown over the last couple of years, it has certainly become easier to get it. Nope, there goes the cat. It has certainly become easier to get it into your house or even into your business, which is pretty amazing, honestly. Stop it, cat. Cat. I am afraid she's going to click a button or turn off my microphones. Give me just a second. Cat, stop it. Cat, please. Please, cat, please. Come here. No. Come here. Oh, CJP is interested, just recently had some work experience with a company that had one. Yeah, I am kind of an expert in CJP. That's like the one tech where I'm like, I really know what I'm doing with this because I did CJP full time for 5 years. And yes, FFF is FDM. The reason why I'm going to call it FDM and FFF, FDM is technically trademarked by Stratasys. So that means if we want to use it in a marketing stance, I would have to get, approval from them. So that's why the industry has adopted FFF. FFF is fused filament fabrication. FDM is fused deposition modeling. These are very typical. We're used to these. And, again, it kind of works, but it can also be a bit of a pain. The thing with FDM and FFF is that you are ultimately limited pretty much. Force Peter says, good luck enforcing that trademark. They really could if they wanted to. Of course, it would really only be for companies that are based here in the States or where they have that trademark enforced. So yeah. But they're the type of company that can just sue people because they want to, not because they need to, right? They're doing it to make a point. All right, Miss Kitty, this is getting ridiculous. I am trying to be a professional streamer here, and no, stop it. Stop it. Miss Kitty. Stop it, Miss Kitty. Ugh. All right. You keep doing this, you're going on the floor, my dear. We have a professional show to put on. I'm sorry, there's now cat hair all over my my microphone. I love you, but yes. Anyways, ISO and ASTM calls it MEP, or material extrusion / polymer, and Dan would likely be the expert to come on to talk about binder jetting, because Dan is a really, really, really hardcore expert on binder jetting. So Dan, we should make a episode of that soon here. I would love to talk to you more about binder jetting, because that is not really my world of things. I know some about it, but it is certainly not my best, to be clear. All right, Miss Kitty, one more time and you're going on the floor. Anyways, catnip in the bed. No, see, catnip will just make her really high and just want more attention, and I'm not about that life right now. But you guys know this is how this goes. Simon's cat live. Yeah, more or less. See, attention also means she wants food, and then eventually she's just gonna bite me. Yep, see. She doesn't bite very hard, but it's only mildly annoying. If I let her rule, she'd be killing the stream and telling me to go pay her attention and not pay you all any attention. So you got to kind of work with what you got. But yeah, FDM, FFF, or MEP is something that is commonly used as the extrusion-based filament 3D printers that we're all used to. Like the ones you see behind me, they are ubiquitous, affordable, and incredibly easy to use. With open source softwares and open source machines, it has brought the barrier to entry for 3D printing down considerably over the years. What this means is that more people can get into it. But we do have a major issue with this industry, is that the education for it has not really followed that. We're hoping to change that here relatively soon, and I try to do that here on the channel as well. But we notice that no matter where you go to get help, whether it's Facebook, Reddit, YouTube, wherever, you're going to get different people giving you different answers for different reasons on different days. And that can be really confusing. And I hope that we can solve some of that here on 3D Musketeers, because that is kind of my goal, to help people get back in printing more reliably, more effectively, and ultimately more affordably. We will have some paid classes coming up in the next 3 to 6 months where we will be going through some of this stuff really hardcore in depth. That way, those that are really trying to tune can tune well. The bed looks like it's going to fall off. No, she's just pressing on it really hard on this side, so the back of it's come up. Don't worry about it. Don't worry about it. Geek Toy Box is here. Mr. Emendon is here. I need a drink. You guys know it. But yeah, we've got a lot of techs in the industry right now, and a lot of you are aware of FFF, FDM, and MEP. But we look at some of the newer players that have come into the industry. SLA and MSLA. Now, technically, SLA was the first patented type of 3D printing out there. It utilized lasers to cure a vat of photopolymer resin. But you might be saying, Grant, my SLA printer uses a screen and a UV light source. That is MSLA, or masked stereolithography. Those are more common because the screens are really, really cheap now, especially reasonably high-end ones, right, that have a lot of pixels. So You're seeing companies talk less about how many, like how large their screens are, but talking more about their pixel density. Because ultimately, with resin printers, when it comes to MSLA, it works more about pixel density than it does about, because layer resolution kind of is what it is, right? The size of your screen matters, but if your pixel density is really low, you're going to get considerably worse prints than you would if you had an incredibly high pixel density. I believe Frozen makes a smaller resin printer that's an 8K, so you have incredibly high pixel density. So you get basically darn smooth models versus running like a, you know, 2K screen at an Elegoo Jupiter size screen like this big that's 2K, and it would be way worse, right? We definitely don't want to get too far into that. But yeah, when we look at SLA, the leader in it is Formlabs, right? 3D Systems has some, and 3D Systems has been doing it the longest. Chuck Hull, who patented the SLA process, is now with 3D Systems, and I believe was one of the founding members of 3D Systems. Don't quote me on that. But they have some of the largest resin-based SLA printers. But those are commonly like large vat-based, where they print from the top down. So instead of it pulling out of the vat, it goes into the vat. So you need gallons of resin. And of course, when you look at some of the big players, you deal with a walled garden, which is sometimes good, sometimes bad. If you're trying to do something on a budget, walled garden is completely out of your range, because when you start looking at higher end 3D printers, if you have to ask how much it costs, you can't afford it. Looking at the walled garden of something like Formlabs, I believe that's actually okay. Formlabs doesn't charge too much for their resin, and they do a very good job of keeping the consistency clean, which is important. When you are looking to keep consistency where it needs to be, having resin that you control is very important. When you do this kind of work that Formlabs machines are made for, you need that stuff to work every time. Move the camera a little bit to get more of the cat in there for you guys. But as Chris Catlett says, Formlab is meh for detail, but it's great for production volumes. Top-down printers are cool, and some of them do float resin on top of glycerin, but a lot of the big boy ones don't do that. They are full vats of resin. Some of the larger 3D Systems machines are just hucked full of resin. 3D Experiment says walled gardens are great when they just work. When they don't, it's really depressing because of sunk costs. I would generally say that if you are starting off in this, you want to avoid walled gardens at all costs. If you are someone that has experience and understands the value that those walled gardens can bring to you, then make that decision based on what you need, right? If you are looking for big resin prints and you need something bigger than a Jupiter, guess what? You're pretty much stuck going into a walled garden, or you're going to be doing it in pieces. And if you're okay with that, that's great. Perfect. No problems. Phenomenal. Happy for you. Just like I'm happy when you guys like the stream and subscribe if you haven't subscribed. And if you do want to support us, Patreon, YouTube channel members are, of course, always a thing. So if you do want to support the efforts that we do here, you can go ahead and do so. Links are in that description down below, as always. Worst Peters says, Formlabs resin is starting at $150 a liter. I believe that's accurate. And yes, that is 4 to 5 times the price of something like Soraya Tech. But it comes with certifiable MSDSs, technical data sheets, and more. And a lot of their resins have FDA biocompatibility or FDA compatibility, where the lower end market and the more consumer grade market is slowly working up into that kind of thing. And while you might say, oof, that's so much money, when you are doing something that needs a lot of production, that needs to be right, and it needs a software that is going to predict things like Z expansion, XY compensation, it does all of this in the software. Where Lychee Slicer is great, or Lychee Slicer is great, it is not a pro-level software. A system like Formlabs' Preform, or the 3D Systems or Stratasys version of it, is a lot more user-friendly and will do all of the hard work for you. Whereas Lychee Slicer can do a lot of it for you, but still does rely on you as the user to get the work done. Now, again, your parts are going to be 5 to 6 times the cost, but when you're selling the parts for 10 to 20 times more than you would out of a consumer-grade machine, does it really matter? But this comes down to use cases, just like you can go get a Stratasys Fortis machine. Those machines can print Ultem, Peak, PEC, and others that are considered upper echelon or god tier materials that don't burn. Period. UL 94 V0 fire retardant. They do not burn. They'll carbonize, but they won't catch fire. And they come with certifications. That's why they cost what they do. Now, there are companies out there that are doing Stratasys compatible materials. I know 3DX Tech has a whole line that is Stratasys compatible, where you can use more affordable materials that still come with all of these certifications into your Stratasys Fortis machines. However, if Stratasys catches you doing that, they're going to null and void your warranty and your service contract, which is not fun. When you look at machines that cost more than 10 grand, you're normally looking at getting a service contract with it. When we were doing CJP heavily, this service contract was $9,000 a year. And that meant that I didn't have to touch the machine. We got parts and labor completely covered. There were no extra expenses needed. The big problem that we ran into was how long it took to get service. That's why we opted to kind of lower the amount of CJP machines that we were running and move into machines where they're easier to service by a normal person. And as Worst Peter says, a trained monkey can operate a Formlabs printer. Yeah, you really can. I would feel comfortable putting a child to run a Formlabs printer before I would put a child to run any other, under Formlabs priced resin printer. Because ultimately, resin is toxic, and we know that. But Formlabs has built this system that now with their flex plates, you don't even have to touch the parts at all until they're out of a wash and cure. They've built a system that is automated for small businesses. And while that is going to be expensive, when you look at the fact that your biggest expenditure as a business is time and people, if you can reduce your need for people and reduce your need for human time, you have increased your profit margins right there. And your ROI becomes a lot easier to understand when the machines can do a lot of the work for you and you need to do less of the work yourself. Going back to FDM and FFF, that is going to be your base, cheap, fast, it just works level of 3D printing. It is incredibly simple to use. Of course, we have open source slicers like Prusa Slicer, Cura, Kirimoto, Idea Maker, Matter Control, and others. And they just work, right? You pick your poison for whichever one you're most comfortable with for its UI and UX, and you do it. But when you start looking at the bigger boys, where you're getting out of the $1,000, $2,000, $3,000, $4,000, $5,000 machines, you're looking at $10,000, $15,000, $20,000, $30,000, $40,000 and more. These softwares stop being useful and you need to go into the ones the manufacturers provide you. We have a couple of machines here that have manufacturer supplied slicers. I do my best to get around them because I prefer to have one cohesive slicer for all the machines that we use. But I will say it is way more work than it is worth sometimes. Sometimes you just got to suck it up and say, I bought into this walled garden and it better darn well work for me. Sometimes though, it's not that easy. It's certainly not that easy. But with the advantage of lower end machines that are pretty darn close, like 70 to 90% of these upper end machines, you can get a lot of the work done on smaller machines and save your expensive ones for the big jobs. It works out well because you have the benefit of having one of these big boy machines, but not always the need to run it on smaller jobs. I will say machines like the Fortis 450, Fortis 900, or even the Fortis 250 from Stratasys. These are FDM and FFF printers. They are fully enclosed. They are heated. They are insulated. and they have the motors on the outside of the chamber. That was Stratasys's big patent on everything, was that the motors are outside of the heated chamber. Their patent was surrounding that. They can't patent the heated chamber, but they can certainly patent putting the motors on the outside. Their patent has since expired, so we are starting to see machines come out with this technology in it because it enables those that do want to print materials like ABS, nylon, polycarbonate, PEEK, PEC, Ultem, the big boy stuff, to be able to easily print it inside of a chamber that is temperature controlled. When you do look at doing higher end jobs, temperature controlling is incredibly important because when you start to have the necessity to document, if you can't document all of your temperatures throughout the build cycle, as well as an annealing process if it is needed, you're not going to pass certifications that you need to sell your parts. Now, you might be sitting here and saying, Grant, I don't need this. I get it. The vast majority of people don't. You don't need certifiable parts. But if you are starting to play in industries that do require it, like aerospace, like automotive, you will need to start abiding by those rules, or you will find yourself at a pretty high risk of a lawsuit. Don't find yourself there. That's bad for business. Lawsuits are generally bad for business, no matter what side of it that you happen to be on. Fotis is here as well. How you doing, buddy? Gregory Pfeiffer is here. Mike Jones says, no matter how foolproof the printer is, if you download a model off of Thingiverse and don't put supports on it, the print will fail no matter how good the printer is on some models. It takes some know-how. It does. It absolutely does. However, a lot of these higher-end slicers are just click a button, it'll do all the work for you, and then you just go about letting the machine do its job. Right? The higher end machines get, the easier they should be to run. Now, I know by and large, this isn't always true, right? Your mileage may vary, but you definitely have to look at it. As Ronnie is saying, hospitals and medical applications are another one. Chemical industry for worse Peter. Hospitals and medical have an entire thing. I believe it's 13845. That's the ISO certification for it, 13845. Someone can correct me. I think it's 13845 or 13485. It's one of the two. Did Mad Cat say something? He must have said, he says, I guess I'm chopped liver. I didn't see that you said something. Whatever. I must have missed it. Maybe you're just trolling me. Who knows? Y'all might be trolling me. I'm pretty sure I said hi to Mad Cat earlier. Chris Catlett says, what is the benefit of Formlabs knowing the material properties of the resin and their auto supports work? It's true. It is very true. But if you're not playing in those industries where certifications are required, go ahead and easily be more than comfortable running affordable machines like the ones you see behind me. But when you do start playing in industries that have extra zeros before the decimal point, your machines will likely have to keep going in that range as well. Now, there are options to add heaters and things like that to your 3D printers, but none of them will basically maintain that as well as a proper system does. Mr. Emendon joining for stickers and Discord. Thank you, sir. Send me an email, I think, although it might actually be connected. So if it works, you should already be in the Discord. I don't see you in there. So if you are not connected to YouTube via Discord, just email me, youtube@3dmusketeers.com, and I'll make sure to get you in there. Ronnie says you need ISO 27001 as well for most because you're storing data of these companies. I believe it's ISO 9001 as well as AS 9100, but I think that's more for aerospace. 13845 covers medical. Okay. Yeah, because we have a local LPBF company, which is layer powder bed fusion, metal 3D printing, that is 13845. And the stuff they do out of there is crazy. I was over there a couple of weeks back and they were just making, literally, we're just making vertebrae. It's so cool. So freaking cool. Ronnie says 9001 is management from top of my head. Yeah, I'm not ISO anything. ISO 9001 is normally where people start. I believe it revolves process control, if I'm correct. And it is very difficult to do process control in this industry. Some people will do that, and I know of a few, Inex 3D, and I forget where Left Terrace is located, but they are ISO 9001. It requires a full process manual for how you do things so that it can be replicated in the event that it needs to be proven how the process went. Oh, okay. And as Chris Catlett said, it is process control. Yeah, gotta love that stuff. And yes, Miss Victoria is trolling you guys for how little she cares about the topic. Yeah, it's a thing. Anyways, FDM and FFF are one of those use cases where you know if you need it. Resin is the same way. MSLA, SLA, and then we have DLP. DLP is one of the easier ones to use, but companies have made it harder, right? So old school DLP was you put a projector underneath a vat and you shot light into it, right? I had a old resin printer, the Kubo Titan 1. If you all want to look that up, that was a Kickstarter printer. Same deal. That was a machine that used a projector underneath, shot light up into a vat, and it didn't mask anything. It was a digital light projection source, or DLP. Zach Friedman did a phenomenal video on DLP 3D printers where he actually took out the DLP source and showed you guys how it looked when it was running. It was so cool. It's basically a bunch of small mirrors that are galvanometers that are then able to either reflect light up or reflect it away, and that gives you your masked effect. Caitlin Marie says, back when I worked for a John Deere factory, we had a couple of 3D printers for creating tools to use on the shop floor. One thing I always remember is how they were always out of service. I don't remember which printers they had, but they always had problems. That is a big thing to look at if you are a business that is looking to get 3D printing. If you don't have trained people that are able to run these machines or a service contract that will keep them running for you, you might be better off outsourcing your 3D printing, maybe to a company like 3D Musketeers, where you have experts that do the work for you rather than trying to find somebody on your staff that you can train or hiring in somebody that you don't know yet. And last thing you certainly want to do is just toss this tech onto someone that isn't ready for it, because the machines will fall into disrepair, they won't get used, and you won't see your actualized value and return on investment on the machinery. You'd be better off outsourcing it to somebody or some company that knows what they're doing to be able to handle it for you and use their expertise and let your people do what they do best, which is their current jobs, and not force them to take on extra roles and probably not pay them extra for it. Welcome to business. But again, treat your people well, give them the opportunities to learn should they want it, and you can start by outsourcing. Start with lower end machines for your people to work on. And then if you want to insource, you can look at buying some higher end machines that might be able to solve your problems 100% versus needing some outsourced and some insourced. It is incredibly valuable to play that game because you don't want to find yourself with a $250,000 capital investment and not have anybody that knows how to use it. That is bad for business. Gregory Pfeiffer says, if you are a business that works with prototyping parts often, especially for just dimensional testing, then considering a resin printer could be incredible value. It would be incredible value. But again, especially like for FDM, I find you can get a $1,000 Prusa. If you want to take your risk on a Bamboo, go ahead. You can go get even lower end Sovol SV06s, right? You can get some really decent printers for very little money these days and be able to mess around and prototype. If you realize that the machines are there to play and learn on, and they're not initially there to make you money, then I think you're moving in the right direction. If you start off with the perspective that this machine comes in, nobody knows how to use it, but it needs to make me money instantly, you are going to have a bad time, a really bad time, unless you get really lucky and that somebody in your shop already knows how to use it. That would be the huge win, that somebody in your shop already has a 3D printer. And if they do, and if they're telling you about it, it might be a good idea to listen because they're telling you about something they have experience in where they can help you. And it's not going to cost you an entirely new staff member. It will definitely and should cost you a raise, but it's not going to cost you a new staff member. That is treating your people right. Simon Cheeseman is here from the UK. Thank you for joining us, Simon. Appreciate everyone coming in and hanging out. Square Peg says this is really good advice. Look, I do my best to give you guys as best advice as I can. And the podcast is more of a let's talk about the nitty-gritties of business. But understand, I am not an expert, right? I have my good months. I have my bad months. We have major successes and even further failures. Business is a cyclical thing. You'll have good days. You'll have bad days. You'll have days where you want to start drop kicking and putting 12 gauge slugs through the machines that you see. And there will be days where you want to marry them. The goal is to have more good days than bad. And if you are having more bad days than good, take a step back and look at why. Why are you having these problems? Is it sales? Are you struggling to bring in money? Well, let's look at your target markets. What are your target markets saying? Are you struggling to have machines that work? Okay. Are you running machines that are reliable? No. Go get machines that are. If you're running an entire farm of enders and wondering why the hell are my machines not working, maybe you should look at why you're running a farm full of enders and not a farm full of machines that are actually reliable. If you are dealing with personnel issues, look at your training manuals if you have them, and if you don't, look at setting them up. You might have staff members that can help you out with this. We did, and we do, that are helping us build a better training manual so that people that join our company are more better understanding of how we do business, so that when it does come time for them to be fully assimilated into the culture, they know what their expectations are, and it's a lot less of drinking from the fire hose and more of, I know what my job is, I'm here to do it, I am competent, I am capable, and I will make you a return on your investment. Having all those processes and procedures in place start the basis of an ability to have a company that is functional. Start with function, then make it be productive. Mike Jones says, I would like nice quality though, because I am starting to see that this is an art form, so that kind of helps, but you're not looking at layer lines when you have something more interesting to look at. I mean, yeah, that's fair. Mike Jones says, yeah, I started off quickly not trying to tweak the machine for quality and got down the rabbit hole in printing function and not so functional but fun things. Quality seemed to improve itself. Yeah. Yeah. Mad Cat says, have an ender and you get one every day. Or you get both in a day. Just like real life, whereas Peter says. And Duff says, let's just ignore last week. Yeah, Duff, I agree. Let's ignore last week. Chris Johnson says, my Prusa Mark 3S was the best choice I made when jumping into the 3D printing hobby. He bought an Ender 3 Pro just to have a printer they could tear apart and tinker with, and maybe get a belt printer mod kit. If you are a hobbyist, a lot of the talks that we're going to do here might not resonate with you the way that you might hope. We do more business-focused stuff here with some of the, touching into the hobbyist industry, but understand that this is more of a time for me to share some of the experiences of business with those that are looking to get involved and grow their hobby into an actual career or a profession, be that at their day jobs or be it in their homes and they're looking to create their own small business. So if you are just a hobbyist, these episodes may not be for you. If you are a hobbyist that's looking to make some extra cash and eventually turn it into a business, you will incredibly enjoy this kind of stuff. Robert Blackledge is here, dude. Hey, hopefully you're feeling better. It was good seeing you a couple of weeks ago. Miss you, buddy. Hope all is well. Speaking of a business guy, we gotta have you on this podcast at some point. Robert's a great guy, good close personal friend of mine. Simon says, I started with an Ender, went to a Guider 2, and now a Voron 2.4 R2. Love them all. Yeah, there are machines that I love, and then there are machines that I love to hate. And it will certainly modify the way that I look at things for the way that I do business, right? Let's move into SLS. SLS is a powdered nylon process. SLS stands for selective laser sintering, and it is exactly what it sounds like. It is selectively sintering layers with a laser. It is really, really cool. Most SLS machines, you can get one from Formlabs. The Formlabs Fuse 1. There are more affordable machines from companies like Sinterit and Sintertech, but personally, I have not seen a lot of good parts come off of those machines. I would like to. And if anyone has any connections at Sintratech or Sinterit, I would love to take a look at one of their machines and really look at comparing it to machines that are higher price and see where does price to performance start to matter. Because I've certainly looked at machines that come off of a Fortis, or I've looked at parts that have come off of a Fortis, I've looked at parts that have come off of Prussias, of Enders. You can get parts that look really similar to those that come off of a Fortis, off of machines that cost 1/1000th of the price. But you must know what you're doing to get there. With a Fortis, you don't have to know anything. You just got to be able to hit slice and then print. That's it. With a lower end machine, you got to know every single little setting and know how it can affect your printer. The big companies don't even give you options like acceleration and linear advance because that's all tuned into the machine. You don't fix big machines. You get somebody else to fix those big machines for you because at that price point, your time is better utilized doing something else. And if you are looking at buying a big machine, look at buying at least two. Because ultimately, if one of them goes down and you can't get service for 2 or 3 weeks, that sucks. Because you're not going to have any machine to run. It's a thing. Ruin says, hello, welcome, or hello, love these shows. Always very interesting and informational. Thanks. Hey, love doing it for you guys. Ronnie says, Bamboo and Ender are the love to hate for Grant. All right, look, my Bamboo has already been sent back, and I am looking forward to getting a new one. And the title of that stream will be Bamboo Unboxing 2 Electric Boogaloo, because I can. But I am hoping that we have a better experience. But I'm certainly not going to lie to you guys. I'm not going to hide anything. If the Bamboo has problems, you're going to see it. And you're going to see it live. That way, I get less people questioning my ethics and more people seeing that, yeah, I'm kind of doing everything that I can. Zach Life Studios is here, says, hey, what's up, bro? Yeah. Jeff says, at the same time, these low-end printers are getting so cheap that it's just better to replace the whole unit. Yep. As our resin printers die, I don't fix them. I will give them to the local makerspace, and they understand that they can just add a new screen into it and go ahead and run the machine, right? I don't want to fix screens. It's not worth it. A $300 resin printer, it's going to take me 2+ hours to fix it. I'll just buy another one. And as a business, if the machine isn't paying for itself in 1 week or less, I'm not buying it. Now, that's for these lower end machines. When we start looking at higher end machines, like when I bought my first CJP printer, I had a 6-month ROI on that. That's what I needed to get. And I had the business case for it, and we did it. But I also had a buddy of mine that I outsourced my overflow work to, so that as we got more busy, we didn't have to start denying jobs. We just had to start extending our lead times. And because he and I developed processes together to make better quality prints and eventually manufacture our own super glue, which is the post-processing material for it, as well as our own binding fluid to give it proper color and better layer adhesion, the parts were indiscernible between ours. Nobody knew if it was something that I was doing or something that my buddy was doing. But that's the deal. If you're going to be doing any outsourced work as well as doing insourced work as well, you better make sure the quality is indistinguishable between the two, because your customers will know if they are, right? It's not bad, it's just business. You have to know when it is time to buy another machine and when it's time to just find somebody with that machine to be able to take over that extra work for you when you can't necessarily take it on. Don't overextend yourself for a singular project. Know that it is good to outsource from time to time, but grow slowly rather than have a bunch of machines that will collect dust, not making you money. Fotis says Prusa shill. Yeah, I wish. Mike Jones says, I was going to get Prusa as my first, took a gamble on something cheaper and not disappointed, but would still consider a Prusa in the future. They seem to care about software, and that's the key. Yep. Jimmy says, if the Bamboo has no problems, will you accept that as well? Absolutely. I was really hoping that my machine wasn't going to have issues, and I hope this new one doesn't, because I would like to actually use it. But, you know, I can't. Fotis is not a troll. Fotis is an honest gentleman who is stand-up and loves everything and everybody, especially 3-letter YouTube channels. Now, Fotis is a good guy and a phenomenal designer. If you guys are looking to get some awesome models for free, you can actually go over to Fotis Mint's page over on printables. And if you're looking to get those models faster, go over to patreon.com/FotisMint and go join, because Fotis makes some amazing models. That Mecha Fox that you just put out is amazing, or Mechana Fox is really cool, and I am excited to print that. Now, Fotis says he's terrible. He doesn't see the value of his own work, but traditionally, those that don't see the value in their own work are those that are normally the most valuable. Those that think that their work is valued higher than, the world itself, and believe that their time is worth thousands of dollars an hour, and they clearly don't know what they're doing, are those false prophets that you don't want to listen to. Those that continually say, there are those that are better than me. I want to be the dumbest person in the room. If I'm the smartest person in the room, I've done something wrong. I'm only okay at this. I'm always getting better, and I always have something to learn. Those are the people that you should be listening to. Self-proclaimed experts, bullshit. Don't listen to it. Don't listen to it. Fotis says he's going to choke. I don't want to know on what, Fotis, but that doesn't surprise me. Mike says just one good trained machine network could possibly make a printer made of elastic bands print nice. It's just really about the compensation. You can only go so far in making it perfectly straight. Yeah. At the end of the day, the software matters a lot more. And if you find a software that you like, be it Preform, be it Prusa Slicer, Cura, or any of the others, stick with it. There's no point in learning a bunch of different slicers if they're not going to be useful to you. Sure, having that extra knowledge is never a bad thing, but you don't want to extend yourself beyond what is reasonable just so you can learn something new if it's not going to be valuable to you. Now, if you're a hobbyist and want to learn new slicers, by all means go ahead, but recognize the amount of time sink that is going to create. If you are trying to turn your hobby into a job and turn it into a business, then you should be looking at learning a second slicer, but doing it in your free time when you're not spending time trying to make money. If you still have a hobby as what you do for a living, that's fine, but understand at some point, those two lines are going to get really blurry, and just expect it. If you do separate the hobby from the business, you might be able to keep it, but a lot of times you might lose some passion in that hobby because you are trying to make money off it. It becomes more of a game of how to make money rather than how to have fun. And that's why we take jobs that are sometimes a lot of fun, but don't necessarily make a ton of money. And I recommend that if you're doing it as a business, you look at that as well. It's why lawyers are supposed to do pro bono, so they don't get stuck in the making money thing. They get stuck in helping others. That's part of it. 3DHP says, I would love to have you drop in on one of my hangouts on Saturday. I think there was once a long time ago. We miss you. Yeah, I used to. I've been streaming a lot more. I've been very, very busy working on products. I have one of the latest iterations of the Politician here, but I'm going to have to rework CAD for it because it's too big. This is a better method for what we were doing, but it is currently too large. I will have to rework CAD. So, Zerno says, did Grant have more passion at some point? That's scary. Yeah. I'm passionate about the things that I do and how I say it, right? And I try not to hide that from you. Matt says the old Grant rants. Woo. Yeah. For those that don't know, I toned down my emotions for this channel because I don't want to come off as like a loose cannon, but I do feel incredibly some type of way about certain things in this industry. It's just the way that it does, right? So, yeah. Oh, sorry. All right. Back into SLS. SLS is a tech that if you're looking at Sinter or Sinter Tech, you can get for like sub 10K. But realistically, I think the Fuse 1 Plus from Formlabs is probably one of the better, more affordable SLS 3D printers on the market. It starts at about 40 grand by the time you're all in. That's for the machine, the sifter, powder mixer and everything like that. And its ecosystem, while closed, is a very, very nice ecosystem. Recently, when I went out to California, I spent quite a few hours with JinkSpot, where they have an SLS machine. In fact, this is an SLS printed part. This is their little logo dude printed on the Formlabs Fuse 1, and it is all made of nylon, so it is very flexible. And SLS is cool because, unlike FDM and SLA, it doesn't require any support material. The powder surrounding it becomes the support material itself. And that is crazy valuable. When you're looking to do parts like that piece that you just saw, that would be 95% supports if it was done on something like resin or FDM polymer, right? You have to look at the type of use case. If you're doing something that's really organic and doesn't have much of a flat surface to print on, yeah, resin would be a good start. But if it's something that needs the quality of SLS, you can't beat SLS or MJF. MJF is multi-jet fusion. It is HP's answer to SLS. Yes, HP actually makes 3D printers. MJF, do I have an MJF part? It looks very similar to SLS. They're difficult to tell the difference. Let me see. I got SLS back. I got SLS and MJF back here. Hold on. Oh God, ripped the camera off. Oh well, that's not going to hurt anybody. Here are, well, they're different sizes, but this is MJF. This is SLS. So this is white SLS nylon. This is natural MJF material. This is technically polished MJF, but MJF is this gray color. It is a binder jetting process where HP uses its experience in jetting ink to jet out a fluid that is then reacted with light. It's not a UV-based process. It's an infrared process where it actually sinters-ish with a binding fluid that colors the part and is able to sinter it, as far as I'm aware. It might have changed a little bit, but yeah. Dan Brunemer is saying it's sometimes referred to as high-speed sintering, or HSS. I generally refuse to call it HSS because that is high-speed steel in the machining world, and I don't want to confuse the two. MJF to me is a little bit easier of a side to do that in. But I was at Rapid in 2016 when HP released MJF, and it blew my mind. I watched the 5000 series MJF machine make hundreds of parts in an hour. It was amazing. The thing with binder jetting and why it is faster is that it does a much larger swath at a time. Your SLS machine is fundamentally limited on the speed of the galvanometer and the speed of the recoder to push powder across. If those two things are relatively slow, your machine will be slow. With binder jetting, like out of the HP machine, it can lay down powder and binder and fusing all in the same basic process, although it technically does one wipe of powder, and on the way back, it does the binding layer, and then it does the fusing. It is really, really cool. And HP has fundamentally changed the way that a lot of companies look at nylon parts because you get the same basic technical data when it comes to strength, tensile, but you're getting it faster, and you're getting it generally more affordably. So it enables companies that want to utilize this tech to get into it for a lot less. To be clear, MJF machines start somewhere in the $180,000 to $200,000 range, so they're not cheap at all. But cheap SLS machines like the EOS Formagia, I always forget how the P110. The P110 from EOS, that thing runs like $130,000, $140,000 as well. And it is much smaller than an HP MJF machine. So there's a lot of value in MJF over SLS. But when you compare the two, other than the way that they look physically, right, they're pretty much the same. I will say SLS does tend to feel better in the hands, but they're both polishable. You can dye them both. The thing is, with regular SLS, it can be a white part that you can dye whatever color. With MJF, it is gray, and you can dye it, but your base color is always gray. So a lot of times, if you dye it, it's a darker color. And as Dan says, major walled garden for both. HP did at some point say they were going to have an open materials system for MJF, but I'm not certain if they ever actually did that, because it is HP after all. I don't think they care about the powder. They care about the ink, because it's HP, and that's what HP does. But yeah, there is... I have some things with HP, because I was really excited for the 580, which is their full color MJF machine. It was out for like 4 years before they completely end-of-lifed it, because it didn't ever do really good parts. Yeah. 3D Experiment says, 3D Musketeers, as your professional 3D scanning service, how are those phone apps like Polycam? I need to scan some sculptures for a local elderly artist. This is pro bono, by the way, for his family. Well, if it's pro bono, then it really doesn't matter, homie. They're going to get what they're going to get. I will say they're not very good. It works, and it's certainly better than, taking photos and sculpting it from scratch, but you're not going to get a part that you can rely on for any amount of clarity. We did a stream yesterday on RevoPoint Range. It is a currently kickstarted scanner. I don't mind it. I'm going to still stick with my Artec products, because smoke them if you got them, and I got them. But I would say Range is a great way if you want to get into scanning relatively cheap. It's not a bad way, but as I've said before, your biggest failure in these more affordable scanners is 100% the software. I love my Artec scanners because of its $1,200 a year software. I would gladly pay more money. Artec, you did not hear this. I would gladly pay more money if they could open it up and let me use other scanners on their platform. I would gladly pay more money, because their software just works. And anybody that watched that stream yesterday saw how easy it is to use. It is literally scan, click, it goes through the entire process on its own. I can just sit back and wait for my computer to do the work. And as somebody that is concerned about time, and your time is equaling money, you need to make sure that you're finding technologies that allow you to use your time as best as possible. That is why SLS and MJF are so popular, because literally you take it's called a cake of material out of the machine, you put it into a depowdering station, and you clean it off, and your parts are done. That's it. This is raw off a printer. There is nothing else done to this. There's no post-sintering. There's no cleaning, nothing. No, the CR scan is not a good scanner. Worse, Peter. It is not a good scanner. Stay away from that scanner. It's real bad. They compared it to the Artec Eva, and when I reached out, Creality never got back to me. I said, well, if you think it's as good as an Eva, I have an Eva, so send me one. Let's compare them. Crickets. Anyways, the software. No, it's not comparatively. It used to be. It was when Creality had stolen everything from Artec, and they are still let me see if they're still currently in litigation. They probably are. Let's see where they are for litigation, since do I still have this tab open? I guess I don't. Oh, yes, I do. There it is. Let's see where they're at for litigation. They're back into discovery. Okay. Well, apparently Kickstarter is... Yep, Kickstarter is dismissed as of February 16th. It is no longer Kickstarter. Kickstarter's no longer a part of it. And now it is just Creality versus Artec. Didn't they steal it? Well, allegedly. We'll see what the courts decide. So they're in discovery as of the 24th of February. So there you go. It is still ongoing. By the way, this court case, the first date that I can see in here is from March 25th, 2022. So we're at almost a full year of litigating this, and we're just now into more discovery. Yeah. Don't get into litigation, TLDR. Nobody wins except the attorneys. But yes, according to Artec, there are Easter eggs inside of the Creality scanning software that is no longer available that meet directly to Easter eggs that they deliberately programmed into Artec Studio. And because of that, and because that Creality poached people from Artec, which is legal, they can poach people, that's fine. But if those people brought over trade secrets, that, my friends, is a problem. That is a huge problem. So, yeah. Anyways. So, yeah. SLS and MJF, they're very similar. They are direct competing direct competing 3D printing technologies. And realistically, if it was my money right now, I'm buying MJF. I recognize that sometimes the parts can be a little bit more expensive in terms of the material cost to come off of the machine. The machine is just so much faster that it doesn't make sense if you're doing something that is production-based. If you need to make 10,000 of something and it doesn't make sense to go get it injection molded, which I can't exactly understand why it wouldn't, but fine. 3D printing in MJF will be one of the more affordable ways to do it out of any technology out there, period. For reference. 3D Experiment says that they'll look into the Connect, look into the occipital structure. I have one. I have a Gen 1 occipital structure scanner. Those things punch way above their weight class, and they attach to an iPad. And that is nice because you need no extra computers, no extra hardware, no extra nothing, and they just work. I believe the Gen 2 is out. It's like $600 or $700. I believe the software for those is much more mature. However, you're still not gonna you're not gonna get anywhere near the quality of my Eva. So again, grain of salt for everything. You gotta kind of work with what you got. And if you try to extend yourself and buy a $20,000 scanner, it's a waste of your time and a waste of your money. We all know this. So don't play the game, right? So let's get into metals. Metals are fun. What? Please tell me you have a plan for Kunovu. I have no idea what that is, Azazel. I have no clue what that is. Green Fiver says, depends on the cost benefit to get the tool made and rent the machine time to get them injection molded. It's true. You would run a break-even analysis, then a cost-benefit analysis to understand what is a better process for you. And of course, as Greg says, not to mention the prototyping and sampling time for the tooling. Yeah. Once you start looking at spending, 10 grand on a tool, you better have your numbers in place. Because if you don't, buddy, that's going to be the worst money you've ever spent. The worst money you've ever spent. 3D Experiments, I hopefully I can help. Ultimately everything is going to be different. If you take a look at the stream from yesterday, you'll be able to see literally side by side Revo Point range versus the Eva range. When it comes out 100%, they're looking to have it around the $1,000 mark. So take into account that the other scanner that I'm using brand new is 20 times the cost, but used, you can get Evas in the 5 to 8 grand range. And I think that they're a good value in that range. Square Pegs has a bit of a question for you, 3D Musketeers. I got a Silva SV06 recently for my hobby of making tabletop terrain. Have you done a review on that printer? Kind of. We did a stream of it. And I have 2 of them. They are amazing. I love them. But you need to be careful not to let them run out of filament. I'm hoping now the SV06 Plus has a runout sensor. They'll start to offer that sensor that you can add on to the SV06. But if you do run out of filament, it is a bear to get it out of the printer. So make sure that you either add a filament runout sensor or make sure that you have enough filament before you start a print, because it can be a pain to get that extruder apart. Anyways, on to metals. There are so many different metal technologies, right? But by and large, you can look at them as the direct metal laser sintering, DMLS, LPBF, layer powder bed fusion, SLM, selective laser melting, and others. I guess I now have to look up Kunovu. I apparently have to look this up because I have no idea what this is. And I'm going to do it right now. Kanuvu, it looks like a freaking ender. Like, yeah, it's an ender. Don't. TLDR, don't. Daniel D says, have you used or do you know much about the Einstar scanner? I have one. It is sitting in a box over here. I like it. There is one problem with the Einstar. It needs so much RAM. It needs so much RAM. I have 32 gigs of RAM in my scanning laptop. It is more than enough for my EVA to run 20 minutes, 30 minutes on and not run out of RAM. I can't run for more than a minute and a half without burning every ounce of RAM on that computer to a point where the computer will completely lock up. The Einstar's software, which is Einstar's from Shining 3D, it is not great. It is not optimized yet. They are still working on it. What I do like about Shining 3D, one, they have a local office to me, and I'm trying to work with them to do some videos. I believe Einstar has a lot of potential, but currently it's not ready. Maybe they've updated their software recently, but for how it stands right now, mine stays in the box. Also, it is one of the most ergonomically uncomfortable scanners that I've ever used, but my buddy Eric Cederberg has an awesome handle for it available on printables. So that's a thing. Mike Jones is a guy with a print farm. He had an order for 1,600 things that took him all week. One asked why not injection, but some orders are too small. Even that one could take a week or more to even mold. If you can get a mold made in a week, you know somebody. Right now, molds are taking 3 weeks to a month to even 2 months to get made, even here in the States. Generally speaking, if you are not going to spend $15,000 to $20,000 injection molding, you really should stay in 3D printing, because your mold is going to cost, a minimum of $8,000 here in the States and a minimum of $2,000 or $3,000 overseas. And remember, when you go overseas, just kiss your IP goodbye, because you don't own it anymore. And even if you did own it, you're not going to be able to afford to handle it. Oh, I had some dropped frames there. Sorry about that. But yeah, if you send your molds overseas, kiss your IP goodbye, because even if you do have a patent overseas, enforcing it is incredibly complicated, because now you must go over there, hire an attorney, fight, and if you're lucky, you get to win. Because remember, at the end of the day, if you get into litigation, the only parties that win are attorneys. Yeah, it's a thing. Gregory Pfeiffer says, if you get a mold made in a week and you can get parts out of it in that time, that's hoofing it. Yeah, you're paying triple to get it done that fast. Warfear says, could that maybe be a memory leak? Over 30 gigs of RAM is not common for prosumer software. I will say, I can send you the software, Peter. It's free software. If you want to look at it, it is still in dev mode. They have not actually released it outside of dev mode. So I think it's not processing everything correct. And I think it's saving all of the scan data into RAM rather than some other way. I don't exactly know how they're doing it. It's not my industry. And quite frankly, I don't care to know. Because again, I know what I'm good at, and that's it, right? Do what you know, let others do other stuff. Dan says, well, you can get an aluminum tool, short run, like 10K parts for $4,000 to $6,000 on some factors and relatively quickly. That's true. But if you are looking to do long productions, 10K parts is not worth $4,000 to $6,000, right? That's basically adding $1 to every single part. And Dan knows this. Dan is, for those that don't know, Dan is probably one of the foremost experts in binder jetting 3D printing and has a company that is doing some crazy stuff in binder jetting. And Dan, you need to come on this damn podcast. We got to make that happen. Yeah, LPBF metals. Okay, so if you're playing in aerospace and you're making stuff for rockets, you're metal. S.J. Jones is probably one of the best people that I know for metals. They were on an episode with Joel Telling talking all about Inconel 618 Inconel. And that is a material that is what we use to print rocket engines. And when you think that we are literally 3D printing rocket engines, it's objectively cool. Terran Space? No. What the hell is the space? The space company. What? Terran Orbital? Is that their company name? Maybe. There's a company that their entire business is based on StarCraft jokes and StarCraft references, but they are doing like an 85% 3D printed rocket. Like the entire shell of it is 3D printed. I believe Veritasium did a video on it. Mods, if someone can find that video from Veritasium and post it, that would be amazing. But yeah, so much is going on with the power of metal 3D printing. Locally, we have a company that is doing medical parts. The owner of the company works in the medical industry and has worked in the medical industry for years. And they got into metal 3D printing so that they could get parts out faster and easier to people and make them more customized to the individual that needs it, rather than trying to hack up something that's off the shelf and make it work. Particularly when you're dealing with things like spinal fusions and plates and metal in the spine. If you can get something that's custom made for you versus something that is one size fits all, wouldn't you rather have something that's made specifically for you rather than something that's made for weight sizes between 100 and 250 pounds? I certainly would prefer something that is specific to me. And I am apparently dropping frames. So let's see. Sorry. I am going to run a ping test to see what's going on, because I am apparently dropping frames, which is weird. We don't normally drop frames on the set inside. But I'll just have to call Spectrum again. Go figure. Anyways. When we look at metals, the bulk of what people are doing is not stainless. It's not aluminum. They're doing materials like titanium, tungsten, hardcore metals that are very difficult to print otherwise. It is a lot more complicated than you think. But when you compare it to something like SLS, the technologies are pretty much the same. They work fundamentally the same. It is a laser that is melting layers of powdered metal, right? It's really cool. As far as I'm aware, and from my understanding of at least the concept laser machines that this local company has, the chamber heats up very, very hot, something within a few degrees of the melting temperature of the material. And then the laser selectively brings it over that level, creating the thing, right? Creating the actual melted area. Metal 3D printing is one of the coolest things to watch. You'll watch it through some thick insulated glass, and it's just really cool to see a laser burning metal powder. It is just objectively cool. Caitlin Marie says, would it be a pro stream if you weren't dropping frames, though? Well, we have dropped 6,836 frames, which is 2.8% of all the frames that we have sent. I don't like that. I prefer not to have any drop frames. That is my personal preference. I'm running a ping test to see if it is my internet or if it is my computer, and I will sort that out toward the end of the stream. 3D Experiment says, I'm currently learning Onshape for learning CAD. What do you use for your business? Currently only selling gift prints, but want to expand my offerings for the industry. We use Fusion 360, specifically because Fusion has an integrated cloud system that also handles version control. And that allows us to have staff members spattered across the country and still be able to maintain version control without having to deal with emails. Gregory Pfeiffer says, titanium and tungsten are quite difficult to process via subtractive, but I could see them being easier to make via additive. On the subtractive side, if you're doing hardcore metals like that, a lot of times you're using an EDM where you've milled a, is it carbon? What the hell is it made out of? It's a black material. I believe it's carbon. And you're burning that into the metal. That's how a lot of hardcore titanium stuff would be made. But yeah, you need really, really high-end tooling to do titanium and tungsten and all that when you look at subtractive. And to be clear, on the additive side, metal starts at $500,000, right? Pretty much you're not getting in it for less than $500,000. And you need dedicated people. The local company was flying somebody in 3 to 4 days a week to run their machines. That's how tough it is to find qualified people to run them. They were flying in somebody from Pittsburgh for a few days every week to run their machines. We were supposed to be doing a video with them at some point, a whole series on running metal 3D printers, but we've never gotten that in the books. I need to get that in the books this year. That would be a lot of fun. But yes, when you look at space travel, specifically with how we get the fuel and cooling to the engines themselves, there are processes that just don't work subtractively. They just don't work. So we need to do the additive process. And additive allows you to do, tubing that is made out of a material that can handle heat. That is not rubber or metal or, abraded metal. It is made of a material that is as strong as the engine itself. Things where we can't put a drill through it because it needs to go around and snake around things. Internal geometry. That's not possible any other way, right? This is all what we use traditional manufacturing and say, you are not good here. It is time for 3D printing to come in and be the useful side of it. But there are cases where you might choose to do some of both, where you do a metal 3D print and then mill it down to get it into the correct sizing. That is very much in high accuracy jobs, where we're looking at things like turbochargers or internal components inside of engines like F1 engines and that, where they will 3D print the connecting rods for their motors, but then they'll machine out the surfaces on them to make them hit exact tolerances. They deliberately print it a little small so they can bore it out and make it perfect. That is where you see that synergy between the two processes. And that is incredibly valuable when you look at it from a business case. Bill Todd got it. Graphite. It's graphite electrodes. Okay. Thank you. I'm like, I know it's black. I don't know. Is it carbon? It's graphite. It's graphite. It's graphite. Mike Jones says, nice. In space, you would need to heat metal to fuse iron powder. They would cold fuse. Oh, you wouldn't need to heat metal. You just have to deoxidize them, which might need some heating, but not melting like we do on Earth. Maybe a real reason to set up in space station. I mean, the issue is that laser sintering machines use a ton of power. Not only are they heating up very, very close to the melting temperature of the materials that they're printing, they're also filling the chamber full of an inert gas. And some of it is because the laser is so powerful they can ignite the oxygen in the air, but the bulk of it is because if you put an inert gas, a lot of times it is going to be argon or nitrogen. If you put an inert gas in there, it keeps the metal from oxidizing. Because yes, as you heat the ever-loving crap out of a metal, it will tend to oxidize very rapidly. And if you can put it into an atmosphere where there is no oxygen, no oxidizing. It is really, really cool. But you also have to remember that heat up and time to come to temperature can take hours or even a day. So often when you're running metal 3D printers, you are waiting until you have enough parts or someone is paying a significant amount of money. You're spending hundreds of dollars on inert gas just to fill the chamber. And if you have a leak, sayonara, right? And a lot of these metal printers do leak gas. Why? I don't know. They just do. It is a common thing where you're burning a lot of argon and nitrogen. But remember, when your print is done, you vent that noble gas. The chamber has to come back down slowly, and then you can take your parts out, right? It's not like with an FDM printer where the parts can come out 5 minutes after the print is finished. No, it's taking 12 hours to come to temp. It does the print, then it takes another 12 plus hours to come down from that temp. It's a lot more laborious than you would think. Oh, and support material? Oh man, whole nother world for metal 3D printing. As you might suspect, breakaway support, not possible-ish in the metal 3D printing industry. So a lot of times you are building models that have minimal support. And while, yes, the powder can provide some stability, it will not provide as much as you need. You ultimately need a lot more stability than just the powder can provide to you, because as you create solid metal structures, they get very dense and very heavy. And you're not compacting the powder like a pill would. Like, you know, the powder-based pills, those are compacted, so they're a lot easier to work with. This is not done like that. And you'll have issues where the parts can start to warp, very similarly to how we have it with FDM, where your materials can warp. The supports will keep your parts from warping and keep it dimensionally accurate. Because if your print head hits a part on an FDM, okay, you skip a step, it's no big deal. You don't hurt anything. If your recoder crashes into your metal part on your metal 3D printer, it's made a $20,000 noise. You're lucky if it's only a $20,000 noise. The damages that can get caused from failures in the metal 3D printing industry can be catastrophic to the machines themselves, right? And some of these machines are able to detect these type of issues, whether they have a laser to detect any surface inaccuracies, or like Velo 3D with that big Velo energy, they have a contactless recoder system to where the recoder doesn't touch the powder. So if you do have a little bit of warp, the recoder's not going to hit it, and you're not going to have an issue where your entire machine just says, rip. Because that's bad. Those mistakes cost lots of money very, very quickly. Eddie Monroy is asking, are they using 3D printers in the International Space Station? Yes, but not any laser-based. There's way too much risk in laser-based printers up in space at this moment. They're using FDM, FFF printers up there, so they have one of those up there. Certainly a lot easier for that tech because it is not gravity dependent. Trying to push powder and keep it from floating away is much tougher than it is for a plastic to touch another plastic and not float away. And yes, you can use lasers, like a CO2 laser, to do laser sintering. It is just really slow. There are some open source projects out there that will take like a 40 or 50 watt CO2 laser tube and turn it into a laser sintering nylon printer, but it's not great. It's not great. So binder jetting. Binder jetting, I'm going to look specifically at the X1 process. X1 is a really cool tech and something that Dan Brunemer could incredibly speak to. I am not an expert on it, but as far as I'm aware, binder jetting is exactly what it sounds like. They start with a metal powder. I believe it's normally a steel, and you then use a binding fluid to hold it together. That binding fluid is baked so that it's basically gluing the particles of the metal together. Once the print is finished, and it's a cold process, right? Once the part is finished, it goes into a sintering oven where that binding fluid is burned off and you're infiltrating it normally with a brass, I believe. Dan will know this way better than me. I have a couple of parts from the X1 process. They are useful in specific applications when an alloy of metal is acceptable. But it is also one of the more affordable methods of metal 3D printing, because there is FDM-based metal 3D printing as well, right? Because X1 is now owned, as far as I'm aware, by Desktop Metal. Desktop Metal was one of the first ones to come out with an FDM metal-based printer. Personally, I prefer the Walled Garden of Markforged for that kind of thing. Their Metal X and their X7 and their new FX20 all have their program called Blacksmith. Blacksmith uses cameras to determine how accurate your 3D prints are and adjust parameters on the fly. That is really damn cool. So that means you can do a metal 3D print. You know the shrink rate of it when you sinter off the plastic and you're leaving it with pure metal, right? But binder jetting for metal is a whole different world where you're actually pouring in molten metal to fill up the cavities of everything. Dan, I'm going to have to do a specific subject on this with you. The binder jetting that I'm well aware of is CJP, color jet printing, otherwise known as full color sandstone. My company set some of the standards for the CJP process many years ago. About 6 years ago, we set the standards for it, where we built out a manual that is now considered the way that most people do it. And I know this because to this day, my parts still look perfect. Very few other companies that are doing this technology have parts that look as good as ours. It is a process of gypsum powder that is laid out with a recoater, and then you use ink jets to selectively spray on ink. It is exactly like your inkjet printer at home, but instead of layers of paper, it's layers of powder. And when the print is over, you're using a vacuum that is built in the machine, which is really, really cool. And you're able to then go into like digging it out like dinosaur bones. It's a really, really cool process. The problem is with any binder jetting process, the green parts before they've been infiltrated with a material are really, really, really weak. And then you deal with this problem of you have to be careful. In the CJP industry, you have a few options. You can use epoxy, which will make parts that are so hard you can't break them. We had a baseball that was dead solid that we vacuum infused with epoxy, so it was all the way to the center. And we had a $500 bounty on if you could break it, I give you $500 cash. Nobody could break it. We ran it over with cars, hit it with sledgehammers. Nothing could break this part because that epoxy is what made it strong. Traditionally, though, you used superglue as your infiltrant. And because you are using a basic material and then you're applying an acid to it, superglue is generally fairly acidic, it gets very hot. And so we decided to make our own superglue that has a particular formula that would cause it to catalyze very slowly and not start to smoke. Because I will tell you, if there's one thing that you never want to deal with in your life, that is dealing with smoke from a superglue-based project. One of the original founders of my previous 3D printing company was a Marine. And he said that the smoke that was produced when we were experimenting with the superglues was worse than CS gas. It got to a point where we smoked out the building so bad, we just had to leave for the day and turn on all of our vents. We had a pharmaceutical-grade fume hood, and one of these things started catalyzing so quickly we couldn't vent out fast enough. It was, boy, that was a time. I'm so glad we got past that. Oh, man. So glad we got past that. Madcat USA says cyanoacrylate contains cyanide. Does it? I've been exposed to a lot of it then. Dan says that some parts can be infiltrated. Some are fully dense metal when it comes to binder jetting. Yeah, Dan is going to be the expert in that. I will absolutely concede to whatever Dan says there. Dan is absolutely the expert in binder jetting as far as I'm concerned. Are the machines the ones that eat what? I don't know what you guys are. I think you guys are talking about something else. Yeah, either way, CA glue when it smokes, bad news bears. Doesn't smell good, makes you cry, and it is certainly not a lot of fun. 42436 Freak says, hey, I finally did it. I destroyed my PEX plate on my bamboo. Apparently, if you let it level without the plate in place, it will just grind infinitely into the plate. I don't. Okay. I don't. I'm sorry. Dan Brunemer says that CJP machines are now international with machines from XYZ Printing and Come True in Taiwan. Ooh, I didn't know that. I'm gonna look that up. I would love. Oh, dang. Yeah. Full color and ceramic binder jetting. Hey, now. That is cool. That would be really nice to get back into that. Well, either way. CJP has been around for so long. Like it's so old that the tech that they use, it uses DDR RAM. Not DDR1, no, DDR. And it does use a solid state drive in the form of a 128 megabyte compact flash card. Yeah. CJP's old school though, but I do like it. It's a technology that I'm really familiar with. And maybe one day I would get back into it. Definitely looking at this Come True company. I apparently need to look back into this. Build volume's good size too. Crazy stuff. Oh, it's desktop. Yeah, the big issue with these CJP machines, like the one that I have a ProJet 660 Pro or a Z Corp 650. It weighs 800 pounds empty. So, it's not like you can just put it in, add it to your studio. No, you need a building for it. I had no idea that CJP got outside of the Z Corp and 3D Systems area. But anyways, then there's PolyJet. PolyJet is, honestly, it's basically Stratasys's answer to SLA and MSLA. I have an Object 30 Alaris. We will be showing that off soon on the channel. It is absolutely an amazing tech. As the name would state, it has multiple jets that basically dispense resin in a very, 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 very precise way. You will get better precision out of PolyJet than you will get out of any resin printer, as far as I'm concerned. You're dealing with 10 to 20 micron accuracy, which is just insane. Now, the thing with PolyJet is it abides by the rules of FDM. It doesn't happen inside of a vat. Dan says that's why I'm a jetting fellow. Dan, we got to talk more about this kind of stuff. I love PolyJet, but boy, howdy, is it expensive. It is one of the most expensive techs that we have, and there really is not a great, third-party market for it. I have not found PolyJet replacement materials from third-party companies that I'm even willing to try, to be clear. And recently, it was formally controlled by Stratasys with their J750 and J850 that is able to do full color, clear, and be able to adjust the durometer of the material. Durometer is the flexibility. So you could have soft and rigid parts in the exact same print, which is objectively really freaking cool, right? Having all in just one print done, right? Their support material is, normally you can use a pressure washer to get rid of it, but some of it is water soluble. But now Mimaki, which is a company that has effectively controlled the prosumer to light industrial 2D printing world, came out with a PolyJet competitor that, it's better. I prefer the Mimaki over the Stratasys all day, every day. If you know the company Leica, they made movies like Paranorman, The Box Trolls, Kubo, and the Two Strings. Every one of the movies that I just told you guys is stop motion animated via 3D printing. And that is cool. They utilized CJP for Paranorman and The Box Trolls. Kubo and the Two Strings, they utilized a beta unit of the Stratasys J750. Because while CJP is a great process, its color is not consistent. As your print heads wear out, so you need to replace them, the color will change. And 3D Systems, I'm not going to get into the fact their color is not my favorite, but anyways, as your print heads wear out, your color changes, okay? And when you're doing a stop-motion animation movie where your color needs to be consistent, you need something that doesn't have that problem. And PolyJet was the way to do that every time. And so they went over to it for Kubo and the Two Strings, and they are still using it to this day. The cool thing about PolyJet is that it is very fast, and it comes off the machine ready to go. There might be some support material, and the bummer with that is where the support material touches, your part is matte. It's not shiny. So if you want it to be shiny, you have to then buff it, literally with a buffer, like you would buff the paint in your car. That's okay if you know what you're getting into. if you don't expect that and you're doing a part for like a film, a lot of times they'll tell you, hey, put support over the entire model, even where you don't need it. So your surface texture and your surface color and all of that is consistent. And if you need to buff it, you buff the whole thing and not just the one area that needs it. It's a thing, and it's always been like that. But similarly with the polyjet material and support, you do have breakaway support. As we see tool changers and multi-material FDM 3D printers start to become a thing, people will realize that breakaway support material is amazing. Whether you're using dissimilar materials like PLA and PETG, or you're opting for soluble support material like PVA or HIPS, huge opportunity there. But when you're looking at the Stratus and Mimaki, they have an actual binder fluid, right? The polyjet binding fluid that is soluble. And whether it is a breakaway or mostly soluble or semi-soluble, it exists and it enables you to have parts that come off of a printer with minimal extra work needed that are end use ready to go. That is the value of these technologies. But when you look at the competitor is $250,000 and the Stratasys ones are around $500,000 for the big boys and their J55 is about $110,000, they are still out of the reach of the vast majority of consumers. But that doesn't mean you can't enjoy the tech and get parts from it. It just means they're not going to be cheap. 42436 says, what is the name of the competitor? Mimaki. Mimaki? Look it up. You'll find it. Mimaki 3D printer, you'll find it. Yeah, Mimaki is pretty cool. Mimaki, I think. My text-to-speech thing is telling me Mimaki. Because we are going hard in the paint for content, and that means I have to have a thing that is transcribing me as I'm talking. It's a little distracting sometimes. But, yeah. There's more, right? Concrete, right? Concrete 3D printing. There's so much happening. Cobod is one of the big ones out there. And most of these companies are based overseas, mind you. They make some of the coolest concrete 3D printers. One of our staff members, Justin, who is going to college right now at The Ohio State University, is currently being trained to run a Cobod 3D printer, where he's going to be making buildings and stuff with it. You are seeing a lot of 3D printing home companies pop up around the country, and a lot of them are focused on the affordable housing, because you can build a single family home in 2 to 3 days, all the walls and everything that you would need, solid concrete, and effectively bulletproof when you look at it a certain way, and you just place a roof on top of it. It needs minimal staff members there, needs minimal labor people as well, and it is something that can run 24 hours a day if you decide to staff it like that. The machine needs very few people to operate it, and that means it could cost you considerably less to build homes. Habitat for Humanity out in Tucson, Arizona was one of the first nonprofits to start doing this. And while we do have some companies here in Florida, there's one over in Melbourne that does concrete 3D printing, like they make them. They have an odd name, and I always forget the name of the company. Let me look it up. It is Apis Core. Apis Core is the company over in Melbourne that does it. They use a tract-based concrete printer, but there are others coming out of the woodwork now as well, because that technology enables houses to be built faster, and as far as I'm concerned, safer. As a Floridian, dealing with hurricanes, tornadoes, and the, errant, pissed-off alligator are pretty much a known thing, right? You've bought into this, you know it's going to be a thing, you live with it. I would much rather print my house with a 3D printer out of concrete than I would trust cinder blocks that are held together with a little bit of concrete glue, more or less. There's so much opportunity out there. And if you want Cobod, C-O-B-O-D, you guys can look it up. But yes, as Robert's saying, Florida's first was built by Tallahassee Companies Precision Building and Renovating and Gulf Coast additive manufacturing and design. And I happen to have met the lady that was responsible for this, and she is awesome. I am really going to try to book her for a future podcast to talk all about this. It is so cool. And while they did clean up the house so that you couldn't tell it was 3D printed, I personally disagree with that. I would want the layer lines to be there, both inside and outside. The only downside to having a home that is 3D printed in concrete is if you do not opt to put drywall up and studs, like normal studs, you have to use a masonry drill to hang pictures. So that's really the only downside. But it means that every one of your walls are solid, right? It is so freaking cool. I really look forward to getting her in. I think she would do it because she's as passionate about that stuff as I am. And I want to go up and visit it one day. So, Robert, we'll have to figure out a time when I can come up and visit that house because it would be so cool. It would be so cool to go up there and see that house. Not that I can afford it because I can't afford housing in this market, but it would be so cool to at least see it. Maybe we'll do a video on it. But there is a lot of opportunity for concrete, whether you're doing something that is affordable or you're doing something that is, fast. There is so much involving concrete where opportunities exist for those beyond just the average consumer. Gregory Pfeiffer with the $20 super chat. Thank you, sir. Getting a 3D printed house lets you live the dream of living inside a bunker. If that isn't the most American thing, I don't know what is. And see, I really want to work with a 3D printing company to build a building on my property. So the video title can be 3D printer, 3D prints, 3D printing business, because that's a hilarious video title and I think would actually do well. And it's self-serving because I want to have my 3D printing business inside of a 3D printed building because that's the coolest freaking marketing I could ever do. But yeah, $250K for a 3-bedroom in Florida? That's cheap. Now, I don't know if that area in Tallahassee, that is expensive or affordable, but I can tell you to build a house like that, a 3-bedroom house, does not cost anywhere near $250,000. What is expensive is the machine. A Cobod 3D printer to build a house that is 3 bedrooms is going to run you at least $1 million. The one that they're using, I forget the one that they're using. She told me, and I forget the name of the company, but they are much more affordable, like $350,000 to $400,000. And they're easier to transport. They're tracked units. And I like the idea of a tracked concrete 3D printer because it can then move. I don't have to pour a slab for it. The Cobod 3D printer is a gantry, very similar to a Core XY, but it's just a big-ass Core XY where your nozzle diameter is measured in, centimeters rather than tenths of a millimeter. Okay, it is incredibly affordable. I like the idea of creating affordable housing, not just because I'm in my 30s and would love to have a larger house or another building on my property or more property somewhere else, but because I believe that the housing market is getting so expensive that unless you're making $100,000 a year, you can't afford to own a house. And that is stupid. That is stupid to me. And I believe the concrete 3D printing is going to be the way that we make it more affordable and make it a way that the average person, no matter where you come from, can actually afford to live, because it pisses me off that they can't. And I want that changed. I am definitely not. I'm at a point where as a business owner, I haven't paid myself in so long that I can't get a house. I won't qualify for a mortgage. I might be able to put a down payment on a house in cash, but I won't qualify for a mortgage because I don't have income, right? And if I'm looking at a house that's $700,000, I'm screwed. I'll never get approved. But if I'm looking at a house that's $250K, I can put a significant chunk of that down as cash and be able to prove that I'm not a risk. I can pay for it. So, yeah, as DV Laserwork says, what is a paycheck? I don't know what a paycheck is. MadCat USA says, I have income, but we still can't afford a house. I don't want to make this into a talk about how crappy the housing market here is in the United States and how inflation is terrible and how my house has almost tripled in value, which is great, but I don't own it anymore, so I can't really do anything about that. But it's like, okay, you could sell this house for triple what you paid. You can't move anywhere else. Can't afford anywhere else to move. Concrete 3D printing is a way to solve that. And it's a way to make really cool looking houses. I would leave all the layer lines and stuff like that on there. But yeah. Anyways, Roddy says, be glad you're in the US. In the Netherlands, a cheap house is €300,000 easily. Renting, not an option, as there is a waiting list for 20 years. A decent house is $500,000 minimum. Yeah, no, actually, that's pretty average here too. There are two lagoon communities being built around me. There's the Epperson Lagoon and the Murata Lagoon. They are on either edge of my property. I can see them both. They have homes. The cheap ones are starting in the 300s, which means they're probably 400 grand after everything is done. And they go well into the $1 million easily. These are homes on no land. You know, if you look at buying acreage in the middle of nowhere, bringing out a concrete 3D printer to print a building for you, it is so much easier because it needs so few less people. You can build a community faster. There's a company here in Tampa called Click Print Home, and I've been working with them. They want to do luxury homes that are 3D printed. We'll see if that works out for them. But they're going to be housing their Cobod 3D printer about 10 minutes up the road from me. And as soon as they get that thing in, we will absolutely be filming content on it. You can bet your sweet keister that is going to happen. So why are there so many technologies? Well, as it changes, people want to lock down those techs, and a lot of these are protected under patents, trademarks, copyrights of some sort. So don't be surprised when you look at some of the crazy high-end stuff that you're like, oh my God, this is an extra, zero more than I expected. Welcome to the world. This is how it happens sometimes. But when these patents start to expire, we will see innovation start to really change. Now, recognize there are business cases for every one of these things. And while a consumer is certainly not going to look at buying a $500,000 concrete 3D printer, they can certainly benefit from the fact that it can bring down the cost of housing. No longer will you have to put 100 grand worth of wood into a house. I mean, here in Florida, we don't do that anyways. Unless they're building apartments. I'm watching all these 6-story apartment buildings going up that are solid wood. I'm like, why? Make them out of concrete. No one wants to live in a building made of wood. I want to be in a building made of concrete. Right, my house is concrete block with steel studs. And most single-family homes in Florida are, as they need to withstand wind and, more importantly, debris. Right, wind is not really the problem. It's the 2x4 that shatters your window, and now the wind gets into your house. It's a thing. As Duff says, prefabricated panels will benefit more than 3D printing. It's true, and prefab is a thing. If you could do maybe the exterior of a home via 3D printing and the interior, you could drop in prefab, that would be amazing. Hell, I believe container homes are a completely, utterly amazing thing, and I'm actively looking at putting the business into a container, or at least expanding the business into a container. Mad Cat says Miss Victoria's irritated by her own tail. Yeah, Miss Victoria wants attention. But as these industries she says she wants it. I said she wants attention. Now here she is needing attention. What are you doing, my dearest? What are you doing? No, ma'am. Come here. It's very difficult to lift a cat because they're liquid. They're just liquid. All right. Okay. I'm going to have to hold her or she's going to be a pain for the rest of the stream. We're wrapping this thing up anyways. There is a lot of opportunity out there for people that want to get into 3D printing, whether professionally or otherwise. Ultimately, it comes down to what your needs are in the 3D printing industry. And as this cat knows, sometimes you gotta pay to play. But don't be afraid of it. If you can make a good business case for it, it can make sense to spend that money or outsource it to someone that already has it. At the end of the day, it is about making money for companies, whether they're making parts, they're making printers, or they're making materials. So don't shy away from things because they're expensive. Keep an eye on them and see when they get a little bit more affordable, because it is coming down the tubes. It just might take a little bit. Yes, Kat. 3D Sermon says, will or have I done a primer video on 3D scanning? We did. I wasn't all that happy with it, so we might do another one. It is very tough to do it because the tech changes so often that it's just more complicated. Yes, alligators. Alligators. Are you going to go now? Okay, bye. Tail in my face. Come on, jump. Go on. Thank you. Cat. Ugh. Yeah, apartments made of wood can't end well. Not only will the walls be literally as thin as paper, the buildings to me just don't have the strength. It's just not there. But anyways, yeah. As Greg says, remember to invest in your machinery, whether it is actual machines or the people that are working with you. Never cheap out on equipment and personnel. You need to keep the company afloat. Yes, those people, those machines will be your lifeline. And if you're not going to spend the money to take care of them, why would you expect them to spend their time taking care of you? Now, don't get me wrong. You can get a lot done with affordable 3D printers, but at some point, you're going to get into industries where you need to spend the money. And it just is what it is. Don't be afraid. Make the business case. If you need to take a loan, take a loan. If you need to get an investor, take an investor. That's fine. You can do it. But just make sure you have a business plan set out. Make sure you treat people right, treat the machines right, and don't cheap out. You'll get there, but it will take some time. Put everything into place, surround yourself with the right people, and with a little bit of luck, you too can be successful. It's a lot more luck than you think. It's a lot more luck than you think. Happy people are reliable, and reliable machines are happy machines. When it comes to high-end printers, if there's one thing that I've learned, if you don't keep them running, they're not going to be happy. They need to remain running. They have to. Because if they don't remain running, they're going to either start to dry out. So any of the binder-based machines, if you don't run them, they dry out. If, even on FDM, if you leave material in your hot end long enough, it can absorb moisture. It can create clogs. If you don't use your printers enough, the grease in the bearings can get old and sticky. You want to use your machines as much as possible. If you find yourself with a lot of machine downtime, it might be time to downsize your machinery or hold on to it for a rainy day. I know for us here at 3D Musketeers, we have expanded pretty rapidly over the last couple of years. And that means we end up with machines with downtime. I'm okay with that because I'd rather not scramble to be up all night changing out build plates, knowing that I have extra machines should we need it. But we also do things where, like with our resin printers, we have 11 resin printers. We have one resin printer for every color and type of material that we have. Because I don't want to change tanks, clean build plates, or anything like that. I want each printer for its own separate thing. And while, yes, that is a fair bit of money, they're $300 printers and $500 printers. It's less than $3,000, right? It's nothing. It's so little. Because again, it enables us to be productive. If someone wants gray parts, someone wants white parts, I don't have to run the gray parts first, then the white parts. I have a machine with gray, I have a machine with white, boom, done. Problem solved, we move on. If you're having to constantly do the laborious process of changing out resin colors, changing out FDM colors, you run into a point where you become the bottleneck. The goal of a business is to remove all the bottlenecks you possibly can, to make all the money you can possibly can, right? At the end of the day, it's about making money. If you're not making money or you're not trying to make money, you're not a business, you're a charity. And it's fine. There's nothing wrong with being a nonprofit, but take the tax benefits that come with it if that's your goal. There are benefit corporations or B Corps. Those are, the asterisk for not everyone, but some. But ultimately, your job is to make money. And if you want to make money, sometimes you got to pay to play. There will be times where choosing industrial makes more sense than choosing prosumer or even consumer. And there are going to be some shops that choose to go with consumer because of the price, and they'll slowly work their way up. Some will choose just to spend the money now. Maybe it's going to lower them into a lower tax bracket. Who knows? A lot of these purchases you'll see coming at the end of the fiscal year. It's very common to see that happen. But don't be afraid of it. Look at it as an opportunity to grow your knowledge, your business, and more importantly, yourself and your staff. Because if you're not growing that, it doesn't matter how much money you make. You're not creating an impact that is meaningful and long-lasting. That's what we want to do. We want to help others. FJ Prince says, could you just have separate tanks and build platforms for one printer? Sure, you could. But why would I? There's no point. The machines are cheap enough that it doesn't matter. Even further, if I have one of my printers that dies, I could quickly pull the build plate and tank off of one printer and put the build plate and tank from this one on, re-level it, of course, and then start the print over again on a printer that's totally fine. And then look at replacing the dead printer when I can. It makes a lot more sense to do it that way for me. You guys might find it differently than I do. I'm okay with that. Make the cases that make sense for you. Just because something works for me doesn't mean it's going to work for you. Just because something works for you doesn't mean it's going to work for me. I could be doing everything wrong. I could be doing a lot of things right. I'm certainly not doing everything right. I can tell you that much. But part of these podcasts is also for me to kind of get used to it, right? Get used to talking more about this. I want to do more episodes that are business-based, but I want to get more experts in here. Although I do find it funny that every time we have a guest recently, either I haven't been choosing the right guests. I think we've had some good guests, but you guys show up more to ones where it's just me talking versus when we have a guest. So if there are guests you guys want to have on, let me know. I really want to have Dan on from B-Jetting. Robert Blackledge, you got to come on here one time or two as well. Talk about, the business of business. There's a lot of opportunity. I do want to start getting some guests though, because it is a lot more mentally taxing than you guys think to do a solo show. But again, there's so much out there. I have scratched the surface of what is possible with 3D printing, right? We have FDM, SLA, MSLA, SLS, MJF, LPBF, SLM, DMLS, CJP, PolyJet, and others. Concrete. That's over 10 different types of 3D printing that I can rattle off in my head right now, which means there's at least 5x of that exists. There are technologies out there that I have never heard of, that I might never hear of, but maybe I can get lucky and say, I've got a YouTube channel, and that means you should talk to me about what you do. I don't know. Sounds like fun. I like talking to people, and I like talking with you guys. But yeah, I have faith that there's a lot of awesome things coming in this industry. Oh, and I forgot about chocolate 3D printing. Ellie, Cocoa Press. We're going to have Ellie on at some point. We'll have Ellie on after they release the Cocoa Press, or right when they're doing the big marketing push for it. It is a really cool process. I got to taste some chocolate off the printer. I'm so excited. That will be my poor financial decision of the year. I will be buying a Cocoa Press, not because I need it, but because I want it. There's no reason for me to have it. I just want it. I'm going to be a kid. And I can write it off. DV Laserworks says, this is all learning for me. I am a newbie in FDM, adding to my laser business. See, that's funny, because I have a laser and I barely use it. I wish I used it more. But thing with the lasers, they need constant attention. I can't just start a laser job and walk away from it, because it's heavily involved with, it can instantly catch fire. I prefer 3D printing because I can easily walk away from it. It's very easy for me to do that. And when you have machines that I can trust, we're good. If I have machines that I can't trust, I don't run them when I'm not around. Now, with that being said, don't run machines unattended. You shouldn't do that. Even though you might trust it, don't do it. Be safe. Trust your machinery, but verify. Especially if you're running big machines, you can generally assume those are going to be safe. If you're running machines under $500, you better verify that they're fully safe before you start to run them unattended. But if you're running machines over $500, I would say by and large, as long as you make sure their thermal safeties and all that work, it'll be fine. It'll be fine. And yes, I saw that Ellie did a video with Mandic, with Alan Mandic recently. Chris Catlett says it's because Amber wants it. Yeah, that's fair. And my business card is amazing. That is literally the only reason I still have my laser is to make my business card. Yep, that's the only reason I still have it. The cat left. Cat had important cat things to do, so the cat left. She's the director of marketing. She's got to go do marketing stuff, apparently. Ronnie says, I can run them unattended, at least with smoke detection above them and thermal cam and webcam on them. I don't think I would trust it. I don't, man. The one time I had to take a phone call and I had to walk away from my laser, I peek in and the friggin' acrylic had caught fire. Thankfully, acrylic fires are really, really small and they don't get too crazy. So I was able just to go out there and blow it off. But I always laugh because that was the first time one of our staff had to do a meeting without me. And it was thankfully with a good friend of mine. And I called the client, the friend. I said, hey, how did the meeting go? She's like, can I just work with him from now on? You talk too damn much. I'm like, all right, yeah, I guess so. And yes, I did make my father a fraternity pal. But we've made a bunch of other stuff with the laser. I don't advertise it very much because it is more time than it's worth to me. And for the amount of money that I would need to charge to make it worthwhile to be an actual line of this business, it would be too expensive. We could bring in a staff member, but if we don't have the business case to do it, I'm not going to. And it's not that expensive to keep a laser hanging out. And yeah, the tube does degrade over time, but there are worse things in this world. At the end of the day, there are a lot of technologies out there. Search for them, find them, send them to me. If I didn't cover a technology here, or there's technology here that we talked about that you want a deeper dive into, let me know in those comments and we'll look at scheduling them. If you're a part of our Patreon Discord channel, go ahead and add it into the video ideas list. We have an entire channel for this so that we can make videos that you guys want to watch. I enjoy talking about this stuff, but I also don't want it to be bland and boring for you guys. So seriously, hit me up with ideas. I'd love to start talking and do deeper dives into this tech. So if you're interested in it and you want to hear from a business perspective as well, I'm happy to provide it to you. But we're also going to be looking at bringing on some really cool guests that are experts in their individual industries so that they can talk about it better than I can. I think this is a good place to wrap it up, though, guys. I appreciate everybody coming out, hanging out, and enjoying their time. This was a lot of fun and a good stream. Thank you all for coming out. Thank you for those that have donated. Thank you for the new member. Appreciate everybody's love. I am going to go back to the airport. There's a small municipal airport by me. They're doing an event, and I'm going to go help the guy because he has nobody shooting video. I did some with my phone, but now I'm going to go do it with my nice cameras. So I'm going to go back and hang out with some planes and maybe try to talk my way into going up in a plane later today. Anyways, guys, stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one. Season 3, episode 24. Woo! Making it happen.